So, welcome to a summary quiz on the states of matter and density. What we're going to do is put the questions on the board and you need to try and answer them before I answer them, okay? So we're going to go through about 9-ish, something like that, okay? And they are true or false. So go through them and I'll explain them as we go along. Now, starting off. 3. The gaps between the particles in a gas contain air. The gaps in the particles of a gas containing air. Do they? Do they? Do they? No. Okay. The gaps in the particles in a gas contain nothing. Nothing at all. Okay. Now, liquids and gas take the shape of their container. Yes, they do. Yes, they do. Okay, because the particles are free to move around because there are weak forces between the particles. They are free to move around and there are slightly weak forces. So that, I believe, is yes! So, go to the next one. Solids and liquids cannot be squashed as the particles are very hard. Is it because they're hard? Is it now? Is it? I'm afraid it is not, because the reason they cannot be squashed is because there's hardly any space in between them. They're so close together, so you can't squash them together. Okay, so you can't squash my hands any further together because there's no space. Same thing. Okay, right, let's go to the next one. Gas particles are over 1,000 times further apart than those in a liquid or a solid. Gas particles are over 1,000 times further apart. Do you think that's right? It is. They're 1,000 times further apart than those in a liquid or solid. They're very, very far apart. Particles in a gas move randomly at a high speed. Is that correct? Is it random? Is it high speed? Yes, it is. Okay, because they move at high speed all over the place. They're moving around me right now. They're hitting into me right now. All the time. Okay. Particles in a solid do not move around as the forces between the particles are strong. So particles in a solid do not move around as the forces between the particles are very strong. They do not move around. Is that right? Is that wrong? They're right. They don't move around, but they do this. A bit like a bee. But they vibrate all the time. They vibrate. But they don't move from their spot. I wasn't moving from my spot, but I was vibrating. Right. Next one. The equation for density is rho equals volume divided by mass. Really? Really? I'm afraid not. It is mass divided by volume. Mass divided by volume. I'll say it again. Mass divided by volume. Okay. Ice is denser than water. Well, if it was denser, what would it do? What would it do? What would it do? That's wrong. It would sink if it was less dense than water. And there's a big thing we would not have. We would not have icebergs. Icebergs wouldn't float if ice was denser than water. Wouldn't happen. Titanic wouldn't have sunk. So imagine how that would change history. Just saying. Right, okay, a less dense solid will float in a more dense liquid. So a less dense solid will float in a more dense liquid. Well, that kind of relates to that one, okay? A less dense solid will float in a more dense liquid. That is correct. Ice is less dense than water, which is more dense, and therefore it floats, and therefore there's an iceberg, and therefore the Titanic got sunk. Right. Changing from liquid to a solid is called melting. A liquid to a solid. Changing from liquid to a solid is not called melting. Changing from a liquid to a solid is called freezing or solidifying. Right, changing from a liquid to a gas can occur via evaporation. Can it? Yes, it can. Okay, that's because evaporation happens at any temperature, remember. Any temperature. Any, right now. I'm evaporating now. Out my nose, out my mouth, out my skin, everything. Evaporating now. But boiling is different. That's at the boiling point. Changes of state happen at constant temperature. Changes of state happen at constant temperature. Yes, they do. Okay, temperature doesn't change whilst it's changing state, and then as soon as it has changed state, it goes up. Now, right, Hope you enjoyed that like I did. Sorry, being a bit ridiculous today, feel like it. Okay, but my students will recognise that's what I'm like in class anyway. So, I hope this helped and gave you a bit of summary.